Hi everyone. The graph coloring is assigning the colors to the vertices in given graph. The criteria is here same color should not be assigned to the adjacent vertices in the given graph. So here if you take this given graph, you look at that we are having the five vertices. All the five vertices are having different colors, but we can minimize the number of colors by using the chromatic number, by assigning each and every vertex with different colors based upon the criteria properly. So in this given graph we are having five vertices, but the number of colors is three. Look at that, this is the brown, and here we are having the blue, and here we are having the green. Only three colors are applied to the five vertices available in the graph. So we have minimized from the five colors to number of colors is now 3. So this minimum number of colors is called chromatic number for this given graph. Here if the given graph is cyclic and if your number of vertices are odd, then we need only three number of colors. For example, here we are having five vertices in the given graph, so 5 is odd number, so we need only three colors for the graph which is having odd number of vertices. Likewise, if our graph is having cyclic graph and the number of vertices are even number of vertices, then we need only two number of colors. That means chromatic number is 2 for the graph which is having even number of vertices. You look at here, 1 and 3 is applied with similar color. Here these two are adjacent vertices applied with another different color. So only two colors is needed for the graph which is having even number of vertices. And there is one of the graph, planar graph, which is drawing on the plane. The edges of the planar graph must not cross each other. That means if you are having the graph like this, so the edges should not cross each other. So like this it should not cross. Okay, so this is about the planar graph. So planar, it is not a planar graph. The planar graph should have the edges without crossing each other. Okay, so the here the edges are not crossing each other. One of the criteria is here the chromatic number must be less than or equal to 4. That means number of colors going to be assigned to the planar graph should be less than or equal to 4. So here we are having three colors, so this is a planar graph. Here we are applying two colors, so this is also planar graph. Here we are having even number of vertices, six number of vertices, so we cyclic graph, and also so we need only the two colors, green and red colors is applied. So this is also a planar graph. And what about this one? What is the chromatic number of this one? We have five colors, one two different colors, so five colors is there. So since it is having five colors, it is not satisfying the criteria of planar graph, so this is not a planar graph. And another one example, here the complete graph. The complete graph in the sense every vertex in the graph will be connected to all other vertices in the given graph. You look at that, here we are having four vertices, one is connected to all three vertices. Like that, 3 is also connected with all other vertices in the given graph. Like that, 4 is also connected with all remaining vertices in the given graph. So every vertex in the complete graph is connected with all other vertices in the given graph. So in this graph, every vertex will be colored with a different color, because you see the criteria is adjacent vertices should not have the same color. Here the vertex is connected with all other vertices, so what we have to do, we cannot apply similar color to the adjacent vertices, so we have to select a different color to all other vertices. So here the chromatic number will be equivalent to the number of vertices in the given graph. That means number of colors are equal to the number of vertices in the given graph. So here you look at that we are having five different colors to the all different vertices in the given graph. Is it complete graph or not? It is not a complete graph because there is no edge from the 3 to 2 1 to 4, so it is not a complete graph. So we cannot calculate the chromatic number based upon the complete graph. And another one is bipartite graph. So bipartite graph is having two set of vertices a and b. For example, this is the set a. Set a is having 1 2 3 4 vertices and set b is having 5 6 7. So here the edges from the same I mean the vertices in the same set cannot be connected. That means there should not be a edge between 1 to 2 or 1 to 3 or 1 to 4, because the procedure for the bipartite graph is the vertices in the same set should not be connected each other. It should be connected with other set of vertices in the given graph, right? So now you look at that, this is one set, so we can apply with the single color. This is another set, we can apply with the different color. So here chromatic number will be 2, that is minimum number of colors is needed is 2. And here this is also a bipartite graph, that this is one set, this is another set. So set 1 is having green color, set 2 is having the blue color. So this is also bipartite graph, but this is not a complete graph, because in the complete graph all the vertices should have edges, okay, connected. All the vertices should be connected with other vertices in the given graph, so it is not a complete graph. Another one graph, special type of graph is tree. Here the there is no cycles, okay, there is no cycles in the given graph, that is called tree. So here every tree is considered as a bipartite graph, because when you are taking the tree there will be a parent and children. Again this child node may have another child, you look at that. So here we can color with this is one color and this level, okay, this children can be colored with another different color. Again these children can be assigned with the color which is available here, okay. So this is assumed as a bipartite graph. The chromatic number for with any number of vertices for the tree is 2, okay, because the again it will keep on go, there will not be any connectivity between these two vertices, okay. So the chromatic number to the tree is 2, because we are applying different color to all the nodes available in different levels of the tree, that means different height of the tree. So this is also one of the tree. Here this is the root node level 0, this is level 1. So level 0 is having green color and level 2 is having blue color. So this is one of the way to apply the colors to the tree. Thanks for watching.